Yes, so now I can see all four of our plenary speakers, and I'm really looking forward to that interesting session. So before we start, I still have some general points to address, and I think we've prepared a slide for this. So it's about how we organize the questions and the presentations. I think the first speaker, so Bas, you can already keep your camera turned on because I will hand over to you like in a minute. Yeah, so I'm really looking forward to your presentation. Bas is the group leader of sustainable service systems in the group. Oh, now we have our virtual housekeeping rules. Yeah, so generally we are streaming or recording the conference via Zoom. And so if you're not presenting, please deactivate your audio and your camera. And in case time allows after the presentations, you can have some questions, but you can also just add the questions to the chat and I will read them to the presenters. When you want to speak, you have to raise your hand so that I can see that you want to speak, and then we can go over to the introduction. So Bas, I'm really looking forward to your presentation. He's a group leader of the Sustainable Service Systems Group in the Energy, Climate and Environment program at IASA. And he's a very experienced modeler and has worked in the Engage project, which is finishing in 2023. And he's going to present some of the results under the title Feasible Scenarios to Increase Climate Ambition. And I hand over to you. You will have about 20 minutes for your presentation. I will keep time and I will turn on my camera if you have like about 2 minutes left so that you know you're close to the finish. And afterwards, we will have about 10 minutes for questions and for remarks. So I'm really looking forward. And I will turn off my camera so the stage is all yours. And yeah, we have to finish sharing our general slide before you can share your slides. Thanks.
Yeah, thank you. And thanks for that introduction. Let me see indeed, before I can share the slides, someone else has to stop sharing them. I'm not sure who is sharing their screen, but be helpful if they would take them off.
Yeah, I agree. So whoever's sharing, could you please stop sharing that? Yeah, thanks. Then
yeah, thanks. Okay, so now you should be able to see mine. Yeah, so thanks very much for this opportunity here to present the results from the Engage project, which is indeed wrapping up by the end of this year. We have been running for more than 4 years now. And yeah, Engage stands for Exploring National and Global Actions to Reduce Greenhouse Gas Emissions. And we've mostly focused on the concept of feasibility in scenarios and how to increase climate ambition. We are a consortium of 30 partners worldwide, and so it's a very large project, heavily focused, of course, on Europe, being funded by the European Union, but having partners from all around the world with national modeling teams, and mostly those teams that are supporting their countries in preparing for the NDCs and the COP negotiations, and so very close to policy making here. And the approach that we have taken in this project is to really focus on feasibility. What makes climate action feasible or infeasible, and what makes you look at scenarios to think, and you think, are they feasible, or what raises your eyebrows or raises concerns? And this can come from many perspectives. It comes from social technical perspective, from political perspectives, from techno-economic perspectives. And so we really here brought together social sciences with modeling groups to improve how we look at scenarios. We really do both global modeling and national modeling with a very large collection of modeling groups involved here in the project. We looked at both mitigation and to avoided impacts and the benefits of climate action, and we evaluated feasibility in the end actually in 2 different ways. One on the level of scenarios as a whole, and one also on the level of individual options. And I'm going to speak about both. And so the first big effort that we did in this project is to look into the different ways of reaching climate targets. The traditional way that you see here in red, basically, is to focus on end of century temperatures and say, as long as we are at our 2 degrees or 1.5 degrees in 2100, we are good. But that led to a generation of scenarios that had basically a lot of delay on the short term and then a lot of negative emissions in the longer term. And this got worse and worse over time. And so we explored the difference between a different strategy where you would be really ramping down emissions on the short term and not overshoot and really go for this net zero equilibrium state, sort of by mid-century, sort of as quickly as possible. And we explored the different benefits and impacts of these 2 types of scenarios. And one key insight is that, well, of course, if you invest now on the short term, it has bigger economic impacts on the short term. And so you see reduced GDPs, reduced economic activity on the short term, but you have longer benefits actually relatively if you between these blue and red type scenarios on the longer term. And so you have a higher GDP if you have on the longer term if you are in this net zero state. It's even stronger if you look at the NDCs. If you look at the difference between these 2 types of scenarios, if you first follow the NDC trajectory for 2030, you see that, yes, on the relative GDP growth is sort of still higher until 2030. And so in the NDC period, it looks attractive. But afterwards, basically, you're sort of making up for the slowness on the short term, and that leads to higher cost over the rest of the century. Also, if we bring into account here the damages, the impacts of climate change, and you look at the differences again between the blue and the red types of scenarios, we see that the blue scenarios, the non-overshoot scenarios, have higher costs. So they go here below the x-axis on the short term, but clearly have benefits on the longer term, also when it comes to avoided damages and avoided climate impacts, because you're able to limit your overshoot and limit your peak temperatures. And so definitely sort of this really underpins a statement to say that short-term climate action definitely has long-term benefits. Then we developed multi-dimensional feasibility evaluation of scenarios. And on the scenario level, this is if you look at a full pathway, and there can be many aspects in a mitigation pathway that make you raise your eyebrows or actually say have feasibility concerns. And that can be related to geophysical aspects. A pathway could be using more solar or wind or any other potential than you think is reasonable. It could be on the economic side, more GDP loss over a certain period of time. It could be incredibly hikes in carbon prices or in stranded assets. On the technological side, you could see upscaling of wind, solar, or downscaling of fossils that is at a pace where it's, not precedented or highly unlikely. You could have social-cultural changes, behavioral changes, dietary changes in a scenario that are of a pace that make you question the scenario. And on the institutional side, there could be a lot of mitigation basically happening in countries that do not have the institutional capacity to actually implement those reductions. Well, and this scenario level multidimensional feasibility framework has then also been used and is basically underlying a lot of the IPCC sixth assessment report scenario evaluation. And there, across all of this, the evaluation of many different scenarios, the main finding is that especially the institutional aspect and the governance aspect is really important here. On the geophysical side, most scenarios look basically fine. There's questions around biomass, how much biomass you use, but you can limit that and still meet your targets. On the technological, economic, and social cultural side, you sometimes see scenarios and certain variants that are that raise feasibility concerns. But especially on the institutional side, we see many scenarios that implement emission reductions in countries that have very low governance quality and low quality institutions. And what we see historically is that if you don't have the institutions in place, it's not likely that you actually deliver on your environmental targets and the implementation of environmental policies. And this is a key feasibility risk to actually meeting climate targets in the future. And so then we have developed now a set of scenarios that include these feasibility constraints and that look at how can we overcome these constraints. And in this new set, so the likelihood of actually then limiting warming and not overshooting your 1.5 degrees becomes really low, right? Under cost-effective scenarios that have that don't consider a lot of these constraints, you could still say, well, there's around a 50-40% of not overshooting the target. But once you actually take these constraints, especially on the governance side, into account, then your probabilities of not overshooting 1.5 degrees actually really drop towards the 10-20% range. But we find that if you actually then combine these constraints, feasibility constraints, with, for example, low demand strategies or high electrification strategies, you can actually improve this likelihood of staying below the 1.5 and minimize the overshoot. Nevertheless, also, countries with high institutional capacity should definitely take more responsibility in the near term and help countries with low institutional capacity to implement their targets. Right, so that is the more regional aspect of looking at this new set of scenarios that we developed. That if you look here in the left graph on the cost-effective approach, you see the OECD and China both having strong reductions, 80 to 70%, but the rest of the world with lower institutional capacity still having 70% almost reductions. If you take these constraints into account, you really see a shift in emission reduction efforts that the OECD and China take on higher targets, and that frees up space for the rest of the world to have lower emission reductions and actually take on targets that they can deliver on. Then another aspect I want to talk about is the feasibility evaluation of mitigation options on individual option level. And here, when you look at the level of individual technologies like renewable upscaling, nuclear, fuel switching, or demand declines, you can look historically and see, have there been any countries that have been scaling up these technologies at a similar rate as we need them in future scenarios? And then you can define a feasibility space, basically saying, well, we see many precedents, we see some precedents, or it's only in crisis mode or in unprecedented cases what's happening here. And so then we have used this feasibility assessment of the option level with national models in the project for many countries, based on a very standardized set of emission reductions by mid-century, looking at under which aspects of these scenarios do we see minor feasibility concerns or severe feasibility concerns. And basically across the many countries and targets, what we see is that the lowest feasibility concerns, basically also meaning where models on the national level could be more ambitious, is around energy demand reduction, around nuclear, but also in the solar and wind domain, there's not very high feasibility concerns. The highest concerns emerge around bioenergy, and especially around CCS capacity, of course, where scaling up of that technology is always delayed and behind targets and unprecedented. And then the final part I want to talk about is post-Glasgow scenarios. And this is an effort that we did across both the global and national scenarios in the project, looking to what are the currently implemented scenarios, what's currently really on the books, what have countries promised in their NDCs for 2030, what have they pledged in Glasgow now 2 years ago in their net zero pledges for the mid-century, and how can they go beyond that? How can we have a Glasgow plus scenario that actually expands net zero pledges to countries and regions that do not have them yet, and what kind of net zero timing would be appropriate for those countries. And the Glasgow Plus Plus scenario that increases the ambition, brings it forward in time by about 5 to 10 years, depending on the country. And we compare that with 2.5 and 1.5 degree scenarios. And so here, what this leads us to is that the current policies are still, of course, leading to high levels of warming. The NDCs that are on the books that are still not really fully implemented would help reduce warming by quite a bit. And implementing the mid-century targets as promised in Glasgow would bring actually warming down to about 2.12 degrees. But there is still a remaining gap to really go towards 2 degrees or 1.5 degrees. Nevertheless, implementing these net zero targets that are on the books by countries definitely is an incredibly step forward. But then if we look at how can we go beyond what is on the books in Glasgow, if we would expand net zero targets to the countries that have not yet pledged those for years that are appropriate with their levels of development, this would actually bring global peak temperatures down to around 1.7 degrees. And if we would anticipate those or bring them forward in time, Glasgow Plus Plus scenario, that would actually bring warming down to 1.5 degrees. So we could really close that gap, but it really requires much more ambition on the short term, and especially scaling up beyond the NDCs and taking on higher ambition on the shorter term. Again, echoing a theme that you've heard before here. We've gone really into the country level scenarios here in how the different countries have different different strategies for meeting those targets. And what you see is that the different national models here in the project really come up with different strategies, like expanding the use of renewables. Others rely strongly on BECCS, biofuel with CCS. Strong reductions, of course, everywhere in the use of fossil fuels and unabated fossil fuels. Biomass strategies you see in Brazil and Vietnam as strong strategies, and others actually focusing more on fossil with CCS, like as we see in, for example, Vietnam. And the different models and different strategies definitely sort of have different models, different countries show different strategies. If you want to learn more about the project, we have collected basically all of the outputs from the project on the Climate Solutions Explorer. So here we combine both this whole mitigation story that you've now heard about with the impacts side and the avoided impacts side. And so there is an impacts explorer that maps the visualization of avoided impacts for different levels of warming. We have many net zero example stories from the countries that participated in this project. And we have national dashboards for how the energy transition pathways and the trade-offs and co-benefits work out for the different countries around the globe. So definitely go to climatesolutions.explorer.eu to find all of this richness of information and use it in your work. And then, one last part here, I think, is around the stakeholder workshops that we did, because we had around 9 stakeholder workshops in this project, half of them forced only online due to COVID, of course. And it was really sort of an elaborate global stakeholder process that we had here. And our sort of key insights from these are, well, online activities can still not fully replace physical meetings, mostly due to the fact that short online meetings need to be short. And you have a real lack of time for people to participate in those. And only physically do you get a lot of longer term attention from people. And one thing that's here important, I think, for ECENP is that what we found that a central platform actually would be really helpful to document the lessons learned in stakeholder engagement across different EU projects. Because, we all reinvent the wheel in these projects, and building upon each other would be really helpful. So I'm going to leave you with the key policy insights here that short-term climate action definitely has long-term benefits, that support for improving the institutional capacity for implementation in low governance countries incredibly important to meet climate targets and reduce the feasibility risk of actually meeting the targets. And in order to close the gap to the 1.5 degrees, we need to have more countries take on net zero targets and be more ambitious in these targets and to bring them forward in time. With that, I'm going to thank you for your attention and looking forward to your questions.
Yeah, thanks a lot for your presentation. I think it was really interesting how you pointed out that the institutional feasibility is very different between the countries and also the strategies are that different. And I'm giving the floor to questions, and I think there's already one hand raised from, Robbie Morrison. So feel free to unmute yourself and ask your question.
Yeah, thanks. I'm kind of interested in the role of open science and the IPCC processes, and I went through sheer hell to get a copy of Asayama et al. 2023, looking at our reform paths for the IPCC. I also tried reading the energy systems chapter in the last working group 3 report, and the first 2 references I wanted to look up were firmly paywalled. Does the open science have more of a role in the IPCC going forward?
Yeah, so you get my personal opinion here because I'm only been like contributing author to IPCC reports here, and this work has definitely gone in to the reports, but not. Yeah, I think on the especially on the so most of this indeed didn't actually go into the energy sector chapter, but most into the mitigation pathway, so chapter 3. And there, with the scenarios, with the scenario explorers, we really aim to make more and more information available, as echoing a bit the discussion that we had yesterday in the plenary of what is there. I think more of these input parameters are available in the latest AR6 scenario explorer than there were in earlier editions. And I think definitely going forward, what we see in some of the others, like in the NGFS work, and so where all of the inputs and so are becoming more openly available. I think this should be the new norm going forward. So yeah, I think open science is incredibly important here in this domain.
Yes, so thanks. Then we have a second question from, exactly. Feel free to unmute yourself and ask the question.
Hi, Mas. This is Robert Pietzke from Potsdam Institute for Climate Impact Research. I was wondering on the last part where you spoke about the stakeholder workshops and if there couldn't be some better learning of each other. And I know I've been very frustrated with stakeholder processes and setting them up in each project, and somehow you have this problem of reinventing the wheel. But do you have any, like, what would be your ideas of going forward? Would there be an advantage of bringing several projects together and doing their stakeholder interactions together? Or, I mean, you also have the problem that people don't want to be addressed by 10 different projects and they have limited time. So do you have any ideas on how to improve this, or how to also make the project requirements different in the way the European Commission puts out these calls?
Yeah, that's a very difficult domain, sort of, it turns out, indeed, because on the one hand, I think the EU from the funder perspective and from the perspective of stakeholder fatigue encourages projects to do stakeholder processes together. And to some extent you can if there's really a close overlap. But I think in practice you also see that if you have too many different demands on discussions to be had during those stakeholder sessions, it simply doesn't work, because you sort of overload the stakeholders with many different perspectives on a single day and different requests from them. And so while I think it's important, I think it should also, it might be helpful to go for smaller scale processes where you sort of have not larger, not try to have a core set of stakeholders follow a project over a longer term and be involved in the project. But it can be more something like the scale of an advisory board that we have seen in the past with other projects, right? 5 to 10 people actually sort of going with you all the way, and that could commit to being engaged with the project. Might be easier to organizing these meetings of 50, 60 people many times. And if every EU project wants to do that, you have just too many demands on the same people in the end. But I think a discussion with DG Research would actually be really helpful here on this and how to go forward.
Yeah, so we have 4 minutes left. So Robert, if you, yeah, okay, he turned his camera off. There are also 3 questions in the chat. So if you could keep your question rather short, that we can also have the time to have a brief look at the questions in the chat, then we could do that. Oh, the camera, yeah. You can still ask your question, but please keep it rather short, and maybe also the answer rather short, so that we can have a look at the questions in the chat, and then go for it.
Okay, thank you, Bas, for the presentation. So I have a quick question on the scenarios with constraints and enablers. From that work, do you see some priority areas or a broader envelope of constraints and enablers that you think the community should be working on?
Yeah, I think this. So the institutional side is definitely key, and understanding that better. I mean, that's also the question that's in the chat. I mean, it's very thoroughly underpinned with different ways of quantifying what institutional capacity in the future could look like, and so, but still having a much better understanding of what's going on in that domain, I think, is still very important. Yeah, because otherwise it's mostly the bioenergy and the CCS corners that are problematic in the scenarios that you need to sort of constrain. And the better we are able to come up with better constraints for that and better underpinned constraints for that would be helpful. On the enabling side, yeah, we mostly went for the demand, for low demand, so reducing demand to keep the system small, and for electrification, because that helps. But there could be more enablers that we haven't looked at that are, I think, especially we looked in enablers in the corner of not being environmental policy. And so things that countries could implement even if they would have still not governmental capacity to actually to have very stringent environmental policies as such. Okay, so thank you again. If you want to give a really short answer to the questions in the chat, I think you can see them, then feel free to do so. Otherwise, you can also feel free to type it out in the chat while I introduce our next speaker. If you're not, yeah, maybe that's easier. Do that. I'll put a few references in the chat to what's underlying this. Okay, yeah. Then I introduce our next speaker, who is Zita Whale from the School of Engineering at the Polytechnic of Porto, where she's a professor, and she's interested in artificial intelligence, smart grids, and many other topics in that field. And she'll present some results from the TradeRes project. And you again have around 20 minutes for your presentation. After around 18 minutes, I will turn on my camera so you know your time is running out. And afterwards, we will again have some time for questions. So the stage is yours.
Thank you very much. Good morning or good afternoon, everybody. Thank you very much for this opportunity. It's a very nice event, and it's so far being a very nice session too. So I'm here talking about Horizon 2020 project, which is called TradeRes. And TradeRes is about renewables and energy communities as game changers for the electricity market. So, as said before, my name is Zita Whale. I work as a professor at the Polytechnic of Porto in Portugal, and this project is made in scope of our research center, GECAT. My agenda is quite easy today, so it's a short introduction. Then I will talk a little bit about TradeRes project. And finally, I will focus on energy communities, which are an important topic for electricity markets and novel designs for electricity markets. So, beginning with energy as a field. Energy is a very important topic. It has been for many years, but now it is really on the table of almost everyone, from consumers to professionals to politicians and so on. Everyone is realizing that energy is really important, and also sustainability. It's very important to have energy in a sustainable way. So this is why the European Union for many years now is launching more and more ambitious programs on this topic. And clean energy for all Europeans, which is the name of a European package, it's really a very good motto. Clean energy for all. It's a very good motto for our work. So let us look a little bit more at the world, not just the European Union, but I would say that this directive from the European Union from 2019 is really important. We have a package, but we have the European Green Deal, but also at the wider level. We have the Paris Agreement, we have the United Nations climate change. So all these are challenges because, as you know, sustainability is not committed to consider frontiers. And it is very important that the larger possible number of countries commit to measures to mitigate this climate impact that we are having and that harms our planet. So let's look at the energy today. And I would say today we are in the era of smart grids and microgrids. So we are looking at the traditional power systems, of course. The electric networks are still there, but we have a lot of renewables. We have distributed generation. We have active consumers. We have aggregation of different kinds of energy resources. And we aim at sustainable systems, not only from the point of view of energy, not only from the point of view of our environment, but also from the point of view of economy, because this is a difficult point. And those agreements, those international agreements, are not so wide as we would like to, because economy does play a role, of course. So, our main aims here, we want to reduce costs, of course, but also we have players here that want to increase profits. Anyway, we must ensure the added value of the business. And maybe the most difficult question here is how to share, how to distribute that value. This is very difficult and this is not peaceful. So maybe this is the most challenging question. Of course, we are talking about energy transactions, but also we are talking about service provision, because although it's not always apparent, service provision is very important to keep the energy going on to their consumers. It's important that all security issues, all safety issues also are considered, are taken into account, and we ensure that this is a very reliable business. So we must work on business models, namely we must work on different kinds of contracts, more dynamic and flexible contracts, and we must have a lot of work on tariffs. Also different kinds of tariffs that are more adequate to today's scenarios in the energy area. And most of the times we use it to forget something which is very, very important: people. In fact, people are very important for the energy business, but for a long time they were not really considering the equations that hold the business. Today it's becoming different. European Union has put a focus on consumers, citizens, customers, and so on. So it's very important that professionals in the area, in their models, also consider this very important aspect. And when it comes to energy and to electricity markets, we have many aspects that really are very dependent on consumers, on people behavior. Namely, we have demand flexibility with demand response programs, which can be very complex for people. We have local generation at a very, very micro level. We have also local storage, we have electrical vehicles and so on. And a lot of these can be owned and managed by people. So now some aspects of the project. So TradeRes has a good set of objectives. We want to develop new electricity market designs for almost 100 renewable power systems. And of course, this is a challenge. And overall, this is the main goal of the project. We want to model and simulate the new market agents, procedures, and mechanisms. We want to develop open access tools, and this is important because people will be able to really use these tools for analyzing almost 100% renewable electricity markets. And finally, of course, we must engage the key stakeholders in the development, in the improvement, and in the use of these new market tools. And as you maybe all know, engaging key stakeholders is not only crucial, but it's usually quite difficult. So we must identify the actual barriers in the current models, namely in the pricing and in the energy market design. We must calculate the cost, the value, the price structure of electricity in this new scenario of almost 100% renewable, most of them being variable over time, non-dispatchable, which makes everything very, very difficult. We must conceive, design, and model electricity markets, and these electricity markets must cope with these new aspects and must also cope with the possibility of widely using flexibility products and other options into the system. And finally, we must develop the optimization and agent-based models beyond the state of the art, which are very important to support the project in order to reach our objectives. In fact, agent-based models are used throughout the project and by a good number of its partners. TradeRes has a very strong consortium, sorry for that, has a very strong consortium. We have 7 leading partners, 6 European countries. We have research organizations, but also we have companies in the field. Namely, we have an electric company, an energy optimization company, and a company which is acting in the area of forecasting, namely renewable energy forecasting. So we have partners that can bring to the project the required expertise and focus on this goal of modeling electricity markets and coming with new models and new tools for this market. Then we must look at markets, not only one market in Europe, of course, we are not yet there, but also if we look at Europe, we see, or we can foreseen a pan-European market, but also we must look at the already existing regional markets, national markets, and local energy markets. And if regional markets, national markets are already there, maybe or certainly with some issues for the actual share of renewables, the local energy markets are not yet there really, but they can be very important, the very important building block for the new scenarios. So we start with a scenario from, let us say, today. Then we have the S0 scenario for 2030, and finally we have several scenarios for 2050. Our starting point is 2029, so before the pandemic, and then we go on with more ambitious scenarios. As you see here in this scheme, we have scenarios with around 85% of wind, solar, and hydro, and then we consider scenarios with above 90% of wind, solar, and hydro. And we want to consider this, of course, with all the realistic assumptions that we can consider for 2030 and 2050. So, also we need key performance indicators, in this case market performance indicators, and we have defined almost 50 indicators to analyze the performance of the markets under the current and the new designs, the new models for the markets. Now I will talk a little bit about energy communities. As I said before, energy communities are emerging now, and in terms of markets, we are not yet there. We are already in the state that we have established some consolidated energy communities, but when it comes to local energy markets, we are not already there. Of course, the European Union vision also has a lot of documents and also legislation regarding energy communities. We must look at that. We must look at the energy communities that are already in the field, and we must reflect about the requirements that we need to ensure so that these energy communities can actively participate in electricity and energy markets, not only in their own favor, but also in favor of us all. So this should be both directions. Let us see these directives, namely the most important concepts for energy communities. We have, for instance, in the left concept of renewable energy community, and this comes from 2018, from a directive. And on the right, we have the concept of citizen energy community, which is the most recent one, and it comes from the Directive 944 from 2019. I would say that this directive directive on the electricity market is really important, not only for the market itself, but also for the consumers, the players, all the players in the field, because it is really a very game-changing legislation. So, communities are about local generation, and a lot of this local generation is based on renewables, about local storage, about electric mobility. And we must consider self-consumption, of course. This was not normal some years ago, but now it's widely accepted and wanted. We want to consider demand flexibility, because demand flexibility is crucial to cope with the non-flexibility of the variable renewables in the generation side. We want to consider peer-to-peer transactions, local energy markets, and so on. So we have a lot of new building blocks that are there for us to consider. But if we look at the energy communities now, they have a lot of this. So they have local generation. Some of them may have local storage, electric mobility. But the concepts about demand flexibilities and the efficient use of demand flexibility, the concept of peer-to-peer transactions and use of local energy markets, these are not yet there. So we have a lot of new opportunities. We have the opportunity of resource sharing, maybe not for free or even for free. We have the opportunities of transactions with our neighbors. We have the opportunity to implement efficient transactive energy models. And for that, we need new organizations and markets. Namely, we need good models for aggregators, good models for local markets, and also good models for energy communities. Regarding local electricity markets, we have recently published a book on that with some what we believe is important information in this emerging field. And of course, we have operation data for new players and organizations. So we can have a new set of tools based on this data. What we need is to ensure that the models that we develop are not only realistic, that can be used in practice, but also that they are more efficient in practice to be used, that they will be widely used, and that all stakeholders, including the small players, will be comfortable using them. So, also, we need to ensure real-time decision and action regarding not only the power system itself, but also the energy markets. For that, we need real-time power system analysis, which is a very difficult issue, maybe not for utilities, but certainly for medium-sized and small-sized players. We need real-time simulation and we need real-time decision support. And we know that AI is there, but AI is there mostly on the side of data-driven methods. We have a lot of historic data now already. We have real-time data and we have machine learning methods. So we must use all of that, but also we must reflect on the use of that. These are certainly very useful methods, but we must realize what are the requirements to use these data-driven methods to support the players and markets activity. And I would ask, what about knowledge-based models? Because in fact, what we realize working in the field is that most of the times data-driven methods are not useful if they are used alone. So our research group is mostly based on artificial intelligence, AI, and we have inside the research center this group that is mostly focused on the use of AI in the power and energy field. And what I can say, not spending too much time here, is that this is very important, not only from a limited perspective, but from a wider perspective. So we have been developing based on that. I present here Martin, which is a very important infrastructure that we are hosting and keeping alive in our research center. and this is based on multi-agent systems. It is intended not only for real-time management, but also for simulation and co-simulation. Multi-agent systems are a very important part of this infrastructure, and we realized that one multi-agent system is not enough. But when we start developing several multi-agent systems, there are difficulties. So we came up with models for societies of multi-agent system. And also we realized that when it comes to the lower levels of electricity markets, these are local electricity markets, energy markets, or even lower levels of power systems, there are a lot of difficulties. Usually we talk about interoperability, but more than the requirements for interoperability, we need a common language. We need that each component is able to speak with the other component and they understand themselves. So we are using ontologies and semantics. We are using them from an operational point of view, easing and ensuring that all this is not only possible, but also that the development of the tools and system becomes much more easier and less time consuming. Just to give you an idea of some of the equipment that we are using, most of the equipment is industrial equipment that we can buy from the shelf. We have also some hardware development and design from our site, and this deals with real-time management, simulation, and emulation. I would like finally just to give you some information that may be useful. We believe that open science is a very important concept. We are deploying open data sets inside this project and also inside other projects. Also some open algorithms. So I let you with namely one IEEE site that we have been keeping alive for this purpose. And also we are being promoting worldwide competitions in the area. Maybe you can have a look at this link. Maybe you are interested in participating in the upcoming competitions, or if not, maybe you can use the algorithms and data which are there. And with that, I conclude, and I thank you very much for your attention. Thank you.
Thank you for this really interesting insight into the energy communities and the technologies related to it. I think we have about 7 minutes for questions, and I would also open the floor for questions. So if you have a question, feel free to raise your hand or to use the chat. Currently, I don't see any raised hands, but can also be. Oh, now I see a raised hand. Yeah, Robert, feel free to take the floor and ask your question. Thank you. I'm not sure if it's a problem on my side, but I can't see. Now I can see Robert, and yeah, so feel free to unmute yourself.
Sorry, somehow my computer hung up, so I could react directly. Thanks a lot for the presentation. It sounds very, very, very interesting and like a great idea. Could you specify a bit more how the different actors, or like give an example of 2 or 3 actors, how they would use the tools you provide them for? So is it for long-term planning? Is it for creating better trading strategies? I didn't fully get that.
In scope of TradeRes, we have different parts working on those areas. So we have partners that work on long-term planning, and what they do is to have those different scenarios along time, and they come up with different possibilities and optimized solutions for the share of each production technology for each country. So even countries that are not included in the consortium, that tool will give the optimized solution for the share of each production technology for each country, and also the demand and so on. So in fact, we can of course change the input, because this is based on a set of realistic assumptions. For instance, we have assumptions for the number or share of each production technology which can be reached. We know that we are not aiming at keeping the use of coal-based production, because it's very harming for the planet, of course, with the emissions. We know that we want to increase the use of wind or solar, of hydrogen, for instance. So all that is considered, and that tool brings us, in fact, the macro, I would say, the macro picture for each country for each time. In our case, we are studying 2030 and 2050. But also we have other partners that are looking more on the real-time or day-ahead markets, and this is our case. So in our case, for instance, we have tools that can be used for the different players. So we can, we have simulation, we have a large simulation tool regarding electricity markets, which is called MASSEN. We have been developed that much before the beginning of the project, so it's a long-term project. Let us see, it's a departing point for TradeRes, and inside TradeRes we are using MASSEN not only to simulate all those scenarios. For instance, for 2030, till now we have already simulated more than 150 different scenarios for the whole year, I mean, and for the whole year for each hour of each day. So it's a lot of data, it's a lot of scenarios. And what we can do with the tools is not only to simulate, but also to give decision support to players. So the tool has the possibility to learn when the simulation starts. It learns with the actions of the different players, and it will use different algorithms to give decision support to each player. So we can put their players with different supporting algorithms, and they will, of course, have different results. But what we see is that really they can improve their strategy, they can improve their bids, so that their goals are better achieved with this decision support. And also we are working not only on day-ahead markets, but also on real-time markets, almost real-time markets, intraday markets. And then we have complementary tools for modeling the local electricity markets. And when we put these local electricity markets into the play, we can have their bids into the wholesale markets, and we can see all the impact.
Thanks.
Yeah, that was very interesting. Thank you. I would then ask about one question in the chat, but I will ask you to answer directly in the chat, because we're running out of time and we're starting with the next presentation, and I will introduce our next speaker, who's Matthias Weitzel from JRC, from the Joint Research Center of the European Commission, and he will present on fairness aspects of EU climate policies. So Zeta, if you please could stop sharing your screen, then Matthias is good to go, and please also mute yourself during his presentation. And then Matthias, the stage is all yours.
Thank you very much. You should be able to see my screen now. And yes, as you just said, I will be presenting on fairness aspects, but that actually also touches a bit on feasibility, as we've heard in the presentation from Bas, probably at a different level, so not necessarily at the international level, but more at the EU level or implementing certain policies. It draws on recent work that we have done at the GRC to inform the setting of the climate neutrality target in 2050, to set the climate target for 2030, as well as policies under the Fit for 55 package to actually reach the 2030 target. It's joint work with a number of authors, and you'll see references to a couple of slides, so it's not just my own work, but also it's just to make this disclaimer, it's not an official position of the EU that I'm presenting here. Okay. Okay, now I can move my slides. So to start, I would like to use this quote by former Climate Commissioner Timmermans: "If we cannot convince our citizens that the transition is just, there's just not going to be a transition." So you clearly can see the connection already here between fairness and feasibility. But what do we think when we think about just transition? So when we transform the energy system at the dimension that the Green Deal brings about, that can take along some challenges. For example, higher energy prices or cost for energy purchases due to, say, carbon pricing or regulations that make energy equipment more expensive. There's also a shift in certain industries, some job losses as some industries such as fossil industries may decline. But on the other hand, we also have opportunities. So if we increase, for example, the carbon price or the scope of the ETS, there's additional revenues that we can use to offset some of these challenges. There's also new jobs because we are going to invest a lot in new green infrastructure, and we've heard a lot about this yesterday in the keynote speaks. What is required for 2030 and 40? So there is quite a bit of investment happening. So somebody needs to actually build this. Now, when we come to the balance of this, we could also go a bit to something that's really outside my field, but if we think about the behavioral aspects here, going to Kahneman's thinking fast and slow, and loss aversion there, thinking that people are feeling more strongly about losses than the potential to achieve gains. And when we move that into what happens on the streets, we clearly can see yellow vest movements in France, complaining about fuel tax increases. We have recently had in Bulgaria coal miners going to the streets on about fears that they would lose their jobs in the coal industries. Although it's not about climate, but we saw that in London, there were protests about people fearing not to be able to use their cars in the low emission zone. And in Germany, we had recently protests about a new law that would restrict the installation of fossil heating boilers in homes. So there's protests against very specific policies where people think that would be a loss personally for them. And this could then potentially be dangerous for the implementation of the Green Deal. Think about the Timmermans quote that I just mentioned, because some of the groups have actually succeeded in their demands, as for example, the fuel tax in France wasn't implemented after this movement. The law on heating was watered down in partly a response to the criticism. So giving in and scrapping some of the measures would either mean we need to do more later, which then the models would tell us is more costly and potentially thus more difficult, or it would risk missing the targets. A recent column here in the Financial Times would already think that this could potentially derail the green transition, as it is such fears are used strategically by populists to gain support. So how can scenarios and modeling come in here? So at least on costs, we can say something. So when we were looking at the 2050 target, the European Commission has looked extensively at what that would mean. We also looked at what that would mean for overall costs, say expressed in GDP losses. And you can see that there is, even historically, a decoupling between greenhouse gas emissions and economic development. And this is projected to go forward. And then when we increase the ambition to reach the net zero target in 2050, GDP would be a bit lower than it without this target, without considering co-benefits or reduced climate impacts. The number here that we found in our JSC modeling is about 0.5% to a bit over 1%, depending on the assumptions. And if we translate that to annual growth rate, is actually below 0.1 percentage points, so it's hardly detectable in these situation that we're now, where growth rates go up and down every year by quite a bit. So from a distance, it seems all fine. We just need to go a bit beyond averages to see actually who's affected and why there would be people going to the streets. And to do this, we have been using mainly our computable general equilibrium model at the JRC that looks at the interactions between households, firms, governments, also within firms, so between different sectors, and also between the EU and other countries through international trade. On the input side, we take energy system models that describe the transition in more detail, because that's just what they can do better than what we can do in a computable general equilibrium model, which focuses more on the interactions between households, industry, on the industries as a whole. And then on the outside, on the other side, we downscale the results to actually get more distributional insights or labor market implications. And I'll go a bit more into detail on those in my presentation. And this is because, for example, in the CG model, we only have one single household types, which obviously doesn't help a lot when we're looking at distributional impacts. But first, I would like to focus a bit on the labor market transition. And this, of course, is linked to the prospect of different industries going forward in that transition. And you can already see here, when we did the analysis for 2050, that industries are affected very differently. Not surprisingly, fossil fuel industries would be most adversely affected. On the other hand, there is a lot more demand for clean electricity, so output would go up. And some sectors could also gain, such as construction, because somebody needs, as I said, to build the green infrastructure, and this would happen then here. Impacts on trade, on industry, such as energy-intensive industry, actually depends a bit on the assumptions. So what happens in the rest of the world? If the EU goes alone, they would potentially lose some of it. This was prior to thinking about the CBAM yet. So there we would have losses in some industries, but these would be mitigated or even reversed if the rest of the world also goes to net zero, because then the EU would have a head start and actually gain market shares. However, these output changes translate also in changes to employment, and we can see that employment in construction, power sector would go up, potentially also in agriculture, depending on the assumptions of biofuel. However, at the share of the economy, this is actually a relatively small share of overall population. Most of the population works in services, other manufacturing, and so on. And as an aggregate, they're not affected a lot. Affected a lot, obviously, mining and fossil industries. But in terms of overall employment, they are really tiny shares. So employment impacts concentrate in some sectors. And also, if we look, for example, at the coal mining industry, they concentrate geographically. And this can then have implications for the just transition, because for certain regions, it may mean that this share is not so negligible, neither in terms of sectors or regions. Also, when I was saying service sectors and so on are relatively large, we looked also what happens then if we move from the transition of one sector to another. So if you're moving, for example, out of fossil into construction or so on, and what that would mean in terms of overall demand changes for occupations and skills. And overall, it's very low, partly because the affected sectors are not so big in terms of the overall economic importance in terms of overall employment. And also the changes are compared relatively small compared to other trends such as the demographic shift or automation or digitalization. However, when one moves beyond looking at changes between sectors, but also what happens in sectors, this can change a bit. The picture, for example, here we looked at closer detail at the automotive industry, and you can see already that there is a shift just in producing the same conventional vehicle in 2015, which is the first set of bars, to 2030, which is then the second set of bars. So there's going to be less assemblers, less machine workers because of automation. There's more engineers that kind of work or program the machines in this. But then when we move to producing electric vehicles, this actually amplifies. So there's going to be even less assemblers and machine workers because an electric vehicle has less parts, especially in the engine. There's more information and communication technology professionals and other science and engineering professionals demanded. So within the sector, this can have more effects. There's also effects downstream. For example, service shops are having different requirements, as an electric vehicle, for example, wouldn't need an oil change. So these effects can then potentially be a bit more pronounced at the sectoral level. And also there may be some things that we haven't really considered here, which is not where would we have surplus workers that may not find a job, but also in terms of feasibility of the transition, where maybe there are shortages in certain sectors. For example, think about the scale up of heat pumps and the installers that are needed there. So even though I've focused here more on the labor aspect, I'm now moving to the distributional consequences. And here on this slide, I have the distributional expenditure shares by households. So you can see, for example, that poorer households spend a lot more on food in share of their expenditures than richer households. And this also holds for fuels and power, so electricity and fuels for heating that households need. And of course, if these fuels become more expensive, it's not hard to imagine that this would predominantly hit poorer households. For other aspects, such as consumption of vehicle fuels, it's actually a reverse U-shape. So there, it's actually hitting other population groups more in the middle of the income distribution. If we combine then these information from household data with our numbers from the CGE model that would express the price changes for these consumption categories, we see that depending on the assumptions, we would have different effects on the magnitude of how this would affect households. So in scenarios where we have focus more on regulations, which would keep a relatively low carbon price signal, we would see the effect of fuel price increases is relatively small, but we would get higher effects on the cost of housing, for example, through mandatory renovations or upscaling of appliances. This is reversed if we go to a carbon pricing based scenario where the fuel prices are dominating the effect. And obviously this also holds for transport and public transportation services, where the fuel prices, if increased carbon pricing happens, would then have an effect. So here we can then look at how this actually plays out for the different social groups. So again, we have the rich households at the top and the poor households at the bottom. So we have the 10 different expenditure deciles of households, and then we can see negative welfare effects to the left and positive to the right. And then if we just use the effect of the scenario that uses mainly carbon pricing as an instrument, we see that the effect is relatively large of just the price increase. So if the price increase is felt by households, this does have a significant effect. And also the effect notably is regressive, meaning that the poor households would suffer more. If we use alternative policy instruments, such as regulation or a mixture between carbon pricing and regulation, this actually makes the effect smaller, but also the curve a bit flatter, so there isn't that much of a difference between higher income and lower income households. But this does hide a bit the heterogeneity within groups. So there's the so-called horizontal inequality of differences within an income group. So you can, for example, say that people in the lowest expenditure decile are not concentrated necessarily around this line, but there's quite a bit of distribution. And you can think about certain households living in rural areas, needing to drive, or living in uninsulated houses, and therefore are affected more by energy prices because they have higher energy expenditures. On the other hand, you may have households in the city that doesn't need a car. So you have all different kinds of households within this, and this makes the distribution within a group also quite significant, especially in the scenario where these changes are largest in the carbon pricing scenario. Now, this isn't the end of the story, because as I said in the very beginning, carbon pricing will achieve some revenues. So if we use those and redistribute those to the household, actually the picture reverses. So they're having a carbon pricing scenario with lots of revenues is actually good for the poor, although one needs to still pay attention to kind of the tail ends of the individual groups at the individual income groups. So carbon revenues are able to offset some of the regressive outcomes. Now in this slide before, I used all of the carbon revenues to channel them to households, or all of the additional carbon revenues to channel them to households. In political worlds, there's probably many that want to have some revenues. For example, industry wants to get a share through the innovation fund. We've also looked a bit into, do we actually need to channel all those revenues to households? And the answer is no. But then if we don't use all of the revenues, it may be important to do that in a more targeted manner to, for example, target it to poorer households, and then still make those better off, or at least well off as they were prior to prior to the reform. And an important Fit for 55 element that kind of builds upon this is the social climate fund, that especially has a provision to transitionary give money also to directly to households, or at least allows member states to do that. Focusing especially on these poorer households, we can then further also look how climate policy would affect energy poverty, which we here assume having a high expenditure share, so higher than 10% of the expenditures, and households with less than 60% of the median income. And then you have these households kind of here in this upper part of this onion. There's about 13.5 million that would fall in this category in the reference scenario. And this increases if we just take the price effect into account. But then if we have various revenue recycling schemes that would channel these carbon revenues back to the households, we're actually able to reduce, in some cases, depending on how this is done, the energy poverty incidence. This paper is actually going to be presented by Don van Dijk later in the session on distributional impacts, and this allows me to kind of wrap up with a couple of takeaway messages. So clearly in the past couple of years, social aspects have been gaining attention, so going a bit more from just focusing on the costs, so efficiency, towards more equity, kind of looking at how the costs are distributed. And this has a reason also because some of the policies, such as extending the ETS to buildings and transport, can have more pronounced distributional consequences for households. But the good news is policy can address these potentially negative impacts by using only a fraction of the revenues for targeted support that can already solve a lot of these potentially negative effects. But then there is a high level of granularity needed to understand some of these transitions, both in the labor market and in the traditional distribution questions, because we've seen these horizontal equity cases. So on my last slide, I actually have something, challenges for new scenarios, which was also in the session title. So looking at who's actually affected, kind of going beyond just income groups, but there is more modeling potentially possible to look into urban versus rural, households with and without cars, households with certain heating systems, homeowners versus renters, as they may be affected differently, and so on. And then we can look into how policies can actually offset these negative effects. Which ones? Where are the hardship cases? And then going a bit more towards the labor markets, and then looking at policies there. It seems we're now, I think somebody said yesterday, industrial policies are back. So we're back definitely in an area of where there is strong policy from, say, the Net Zero Industrial Act in the EU, IRA in the US, and this may have implications on also labor markets and skills in the transitions, and potentially looking into labor shortages rather than looking at some of the predominant effect of unemployment where we have looked in the past. But also, is there something that we're potentially overlooking? Because labor shortages wasn't something that was really on our radar, say, 5 years ago when we were looking at the net zero strategy of the EU, but now is something that we're discussing very much in some of these contexts of scaling up certain technologies. And with this, I would leave it here, and thank you for your attention. Thank you.
Yeah, thank you for this very interesting perspective on EU climate policy. I think that was a nice addition to the other presentations. And while we wait for the potential questions and raising hands and turning cameras on, I already have one question from the chat. And that is the increase in agriculture jobs related to biofuels demand? Maybe you can comment on this briefly.
In this particular aspect, it was yes, but that really depends a bit on the assumption. So it's very much driven by how much biofuel is allowed in the system. So in this first round of, say, going towards 2050, in this particular scenario, it was very much driven by just the model kind of deciding the cheapest abatement options. If we consider additional kind of sustainability concerns and limit that to some extent, this is a bit lower. It may actually be kind of a net zero. And then, of course, once we move towards 2050, we have this additional problem that agriculture has a lot of very hard to abate non-CO2 emissions. So that then depends also in terms of the effect within the agriculture in terms of employment. That depends then also on what one assumes on, say, demand reduction in livestock consumption.
Okay, I hope that answers the question. Then we have one hand raised, and while this hand or this camera turns on, there's a question in the chat if you could share the slide with the reference literature again while you answer the next question.
I'll try to do that. Moving to this slide. Otherwise, I think there was this Google Drive, and I can upload my slides there after the chat.
That would be good. Then Johannes, feel free to unmute yourself.
Yeah, hi. Thanks a lot, Maria. I think also we see a really insightful presentation on this distribution implication. I have two specific questions. One is, so in terms of the data, did you consider, I mean, given that the energy expenditure, energy price are important, did it use the kind of the latest, let's say, 2021, 2022 ones, or is it still like, I don't know from what base here the microsimulation model is calibrated to? And secondly, on the social climate fund, which I think, yeah, in the future will hopefully or probably turn out a quite important policy instrument in this round, right, on distribution incidents. So how, can you say a few words on how you managed to implement that, given that it's really kind of a lot of things are still to be decided, as I understand, right, on terms of the money and who will be assigned. So, I mean, yeah, just a few words on how you may manage to implement that. Thanks.
Yeah, thanks. Very, very interesting questions. So in terms of data, so the latest consistent data set for microdata in terms of expenditure currently is from 2015. Actually, it wasn't out when we did this, so this even is still 2010, and this means data is quite a bit different. So here we looked at 2030, so we're projecting 20 years in the future, which means expenditure shares may actually be different. And in that particular case, we just use the expenditure shares as they were in the data. We have since worked on this to to project the microdata forward to make it consistent with the aggregate. So if the aggregate says energy shares in terms of total expenditure would go down a certain extent in 2030 or 40, then we scale the microdata accordingly to bring or to harmonize that. And I think that does make a difference, because that actually lowers a bit the regressive effect, because it's yeah, everybody becomes richer, everybody consumes less energy, so this effect on the poor then becomes a bit less worrisome. So much on the data. On the social climate fund, so we had the advantage that we kind of did our modeling before the social climate fund was actually kind of agreed upon. So we were more informing a bit of the design and kind of like just showing this as a problem. So bring it on the agenda to say, yes, this is important. So if you are considering feasibility, you may also want to think about and extending the ETS to buildings and transport. You should clearly think about the social implications. Now, the Social Climate Fund itself was, of course, a political process in finding it between the Parliament, the Commission, and the Council. Everybody had their own ideas and wishes. So I guess it's a political compromise. But I think some of the elements that we had in our modeling are in there, in the sense that there is some room that is possible to have direct support of affected households and small business for at least a transitionary period. And then, yeah, I mean, we don't even know what member states will do. I mean, there is an overall financial envelope for it, but to actually fill it with life, the member states will need to come up with plans that we will then submit to the Commission for approval in what they actually want to do, and we're not there yet. So we still have to hope and wait a bit until this gets on track.
Okay, great, thanks.
Yeah, thank you. So are there any more questions from the other participants? Otherwise, I would have a short question. I've heard a lot of presentations on the topic of energy poverty, and they all use very different definitions of what actually is energy poverty. Maybe you could reflect a bit on the different definitions for energy poverty and what they mean for the EU climate policy.
Yeah, I mean, before going too much into detail, I will directly again refer you to the presentation by Ton in the session after lunch. But indeed, there are different indicators, and it's the difficulty is to capture the potentially very different concepts and bring it into an indicator. So there is a broadly used indicator of kind of like ability to keep your house warm, yes, no. So it's like a single indicator like this, but it's hard to project, for example. So in that sense, having something which is expenditure based is easier to use in a modeling concept as we have used here. But again, this has different implications, because across, say, different regions, this may be quite different, because where I live in Spain, we have very limited expenditure on heating, but more on cooling, for example. Also, very poor households may not even be able to expand it to actually spend the money, because they're faced by, yeah, I mean, they have very low income, so they cannot even spend energy on money on energy. So actually, they wouldn't even appear here as energy poor in our metric. So there's other metrics which actually look at if you spend considerable below, say, a median household, that considers you then as energy poor, because it assumes you cannot afford to spend on energy. So again, I mean, these are sometimes even contradicting metrics. So I mean, having high or even low, a very low energy expenditure shares. So at least, I mean, this is a challenge. I think there is quite some research going on still in this, and I think the this question hasn't really been fully settled yet. And I guess, yeah, it's again the question of like putting things that potentially have very different criteria to evaluate into a single metric.
Yeah, thank you for your reply. I think I agree with what you said. And I think it's perfect now in time to switch to our next presenter. And if you again could stop sharing your screen so that the screen sharing is available for the presenter. Thank you. Our next presenter is a CGE modeler and economist at the OECD in Paris, and he will present on the public finance resilience in the transition towards carbon neutrality. And yeah, I'm really looking forward to the presentation, and the floor is all yours.
Thank you very much. Can you confirm that you see my screen in presentation mode? Thank you. So hello everyone, I'm going to present a piece of works that we've been doing at the OECD with my colleagues Rob Delink, Elisa Lenzi and Filippo Pavanello, but on public finance resilience in the transition towards carbon neutrality. But before that, I wanted to first introduce the reason why we did so, because that's part of a big OECD-wide project that I think was an interesting move. Of the OECD on resilience in a broad, using a broad definition of resilience. So what I'm going to present is based on two different papers that have been published earlier this year. The first one is the Net Zero Plus report, Climate and Economic Resilience in a Changing World, which is the summary report of all what the OECD is doing, and also a conceptual framework on resilience, the OECD's understanding of resilience. And it's really, so I will start with that and then give you more details on the public finance, which was part of this broadening of the definition in climate resilience. So the definition that is used at the OECD is that building resilience to the impact of climate change itself. Of course, that's the standard definition of resilience, but also designing policy that fully take into account socioeconomic implications and considerations of fairness and equity, which relates to the other presentations that we had already today. So it, of course, includes resilience to climate impacts, sea level rise, temperature increases, tipping points, etc., but also economic resilience, such as material shortages, supply chain vulnerabilities, skills gap, etc., labor market disruptions. So we have a lot of studies that we've seen today that relate to this resilience lens, and public finances, which is the one that I'm going to focus on today. Among the different conclusions of this Net Zero Plus report, there are 12, let's say, steps for government to build climate and economic resilience. I've only selected a couple of them to highlight, but all of them are interesting. So the first one is related to climate tipping points, because these are becoming more and more probable. So that's something that needs to be taken into account. And the report also goes into the way it can be handled by government. So how to build climate strategies that are future-proofed using stress test techniques, and so on. System thinking also is important, to not think in silo, because the resilience has to encompass a large quantity of different topics. And on the topic that we are the most interested in today, also a need for careful fiscal planning. And I will zoom in on this question with the second paper we published earlier this year on public finance resilience. So the idea behind this this paper is that most countries have pledged to some form of carbon neutrality. So there will be a scaling up of climate mitigation at the global level if countries respect their commitments. And there are many different approaches to climate change mitigation. So Matthias has already talked about carbon pricing and regulations. We also have subsidies with tax exemptions and so on. So so there are different approaches, and at the same time, public finance are a bit under stress because of reasons that are not related to climate or not directly related to climate change. For instance, the COVID-19 aftermath with the support packages that were involving a lot of public money. But also within the climate topic, there are some competing objectives for public finance. And very often carbon pricing revenues are in one study taken to finance subsidies to finance mitigation. In another study, they were taken to finance sequestration to achieve net zero, the negative emission part, or to finance the just transition. And so there, even carbon pricing revenues are under some kind of stress. And so we wanted to do a modeling study to evaluate these impacts. So the main contribution of the paper, so we built a net zero emission scenario, only one, and it's not endorsed by the OECD whatsoever. It's just one scenario that we propose to evaluate the different implications and show the different mechanisms. And this scenario is compatible with a 1.5 degree increase. So it focuses on CO2, but with some additional assumptions on other greenhouse gases, it's compatible with 1.5. And it includes the widest range of policy instruments that we could design, which means carbon pricing, fossil fuel support removal, and investment-related instruments. And I will come into more detail in a minute. And we quantified both the direct effect of these mechanisms on public finance and also the indirect effect. You will see in a minute that every instrument has impact on all components of public finances, even though it's not targeting the related components. So to do so, we use our in-house CGE framework, which is the AMP linkages model. So it's a global computable general equilibrium model with, for this study, 26 regions and 37 sectors. We only considered so far CO2 emissions, but we tried to have a broad coverage, including fuel combustion, process, and fugitive emissions. And we retained a 2050 horizon. And we compared two scenarios. One scenario, which is legislated policies, which is based on the energy model of the World Energy Outlook by the IEA, the STEPS scenario, and an NZD ambition scenario where carbon neutrality is achieved by every country in the world. Some of them in 2050, that's the yellow part on the map, and some of them in 2060, which is the blue part on the map. So just to give you a picture of what's going on, so we have, with this scenario, we have been quite conservative, so meaning that there is a lot of abatement of gross emissions, which is depicted in blue here, and we achieve something like 11 gigatons in 2050. These gross CO2 emissions are compensated by sequestration using mostly AFOLU negative emissions, but also some part of negative emission technologies, once again aligned with the IEA scenario, which is the energy model we're using as a basic purpose. And we have equilibrium between the two, which is the net are close to 6 gigatons in 2050, and only in regions who achieve carbon neutrality later than 2050, of course. And carbon neutrality, therefore,
So I think we lost our presenter, or is it a problem on my side that I can't see him anymore?
Hi again, I think I've been disconnected.
Yeah, okay, yeah, we figured that out.
I'm sorry for that.
Yeah, you can just try to share your screen again, and maybe if your connection is a bit unstable, you could try turning off your video to just keep the traffic low. Yeah, thank you.
Yeah, sorry. Sorry for that. Can you tell me if you missed, was it long, the disconnection, or not?
No, I think we did not miss that much. I think,
Okay.
yeah, with that slide.
I'll go ahead. So we have 6 policy instruments, and that's the richness of our study, using these different, the wide range of policy instruments. So we have carbon pricing, of course, like the used as emission trading schemes, such as the one in the EU. But we also have another price-based policy, which is the removal of fossil fuel support. So all fossil fuel support is removed in 2030. We also have 4 more instruments that are a bit different compared to what is usually done. And these 4 are regulations in the power sector. So the shift away from fossil fuels towards renewables is enforced. There are also regulations in the buildings and transport sectors. So commercial buildings and the transport services sector. Plus other policies to stimulate energy efficiency. And regarding the decarbonization of households' energy, both in transport and housing, we use subsidies to trigger investments by households that's linked to energy savings and electrification. So the main challenge with these policy instruments is to inform quantitatively the modeling, use information from the World Energy Agency model, but I'm going to go quickly on this. So the results we have for our scenario is that all policy instruments can contribute to mitigating CO2 emissions. So here you see that compared to the stated policy scenario with the baseline we have, the most of the decrease are in the power generation sector, so regulation in the power sectors, but also carbon pricing, but also CCUS and interactions between instruments. But every instrument, including fossil fuel support removal, household subsidies, has its role in a significant role in reducing greenhouse gas emissions. Now we come to the meat of the paper, which is the impact on public finance. So first we will look at the different policy instruments and see how they impact public finance. So we use here a definition, we show results in net public revenues. So it means the difference between revenues from tax revenues and subsidies expenditure. So if you're above 0, you are revenue generating. If you're below 0, you are expenditure generating. And so if we take the example of carbon pricing, you see that the revenue from carbon pricing in orange also is largely positive in 2050, more than 1% of global GDP. But you also see that there are indirect effects on other parts of public budget. So these are all the other different colors. And so you see that there is a negative impact on fossil fuels, of course, revenues from fossil fuel taxes, production and consumption, but also some, let's say, overarching negative economic depression that leads to lower revenue for carbon pricing. The results for public revenues is positive. So we have more than 0.5% of baseline GDP increase in public revenue due to carbon pricing, but it's close to half the gross revenues in orange. So that's an important point we show, is that the indirect effect can really decrease the potential for financing using carbon pricing revenues. At the other end of the spectrum, you have household subsidies, which are a direct cost to public finance, which do not trigger much indirect effect. The effects are dominated really by the direct cost. And in between, all the regulations and other policies have lower effect on public finance, so less than 0.5% of GDP. But still, this indirect effect can be significant when they add up. And that's what we're going to see in the next slide, where we add up all the effect of the different policy instruments for different regions and see what's the impact on public finance in different regions, not countries, but aggregate regions. And we see that overall, the world, which is on the right-hand part, has a negative but limited impact on public finance. So on average, it's around 1.8% of GDP less net revenues. And So that's manageable. That's not a large increase if we compare it to the level of public finance expenditure, which is around 20 or 30% of GDP. And these losses in 2050 range from 0.7% to minus 0.7% to minus 3%. So there are some heterogeneity, but once again, it's something that can be manageable. The second interesting thing is that some countries might really benefit from fossil fuel support removal, because that's a saving for government if you remove subsidies. But due to the scenario design, these occur mostly at the early in the period, between 2030, and do not materialize in a positive impact in 2050. So it's more than compensated by the negative impacts. So the key takeaways of this presentation are that we found that we had so there are transition pathways to limit climate change to 1.5 degrees that are available, and these are feasible both economically, so the cost is, let's say, manageable. It maintains economic growth, although at a lower speed, slightly lower speed. And also there are some fiscal costs that are, let's say, not completely compensated by carbon pricing revenues, that might not be completely compensated by carbon price revenues, but the magnitude is manageable compared to what the changes public finances have seen in the past decades. The other interesting thing that we showed is that the fiscal effects are actually the composition of different effects that we described. So there are some direct effects that increase public revenue or reduce public expenditure. So these are carbon pricing and fossil fuel support removal. There are instruments that are costly. So in our scenario, it's subsidies, but it could have been financing sequestration and so on. But most importantly, we showed that there are some indirect effects where any policy, even a regulation that has no direct cost to public finance, can have impact on the different tax bases and then could reduce net public revenues. So with that, I'm a bit early. I'm sorry for that, but I will thank you for your attention, and we'll be happy to answer any question or receive any comment. Thank you.
Yeah, thanks for your presentation. I don't think it's a problem that you finished a bit early. You can also try to turn on your camera again for answering any questions, and I would open the room for questions. So please raise your hand and turn on your camera if you have any questions. I think it was a very interesting presentation, and yeah, a lot of aspects to take away and to think about and maybe digest during the lunch break that is following in 12 minutes. So are there any questions from the room? I see one raised hand, so feel free to turn on your camera. It's again Robert, I think. So yeah.
Sorry, me again.
Yeah.
Thanks a lot for the presentation, Jean. I have one question. I didn't fully, or maybe I missed in your presentation, when you have the fiscal revenues from carbon pricing. I mean, we had the other talks before saying, okay, how much do you need to recompensate citizens worst off? And so what were your assumptions on this in these scenarios? So did you take half of that, or did you assume nothing for compensation? So
thank you for this question. That's actually, yes, I didn't say that, and it's something I forgot. So we have taken all the revenues, so all the net revenues from all the direct and indirect effect that we redistributed fully to the households with a lump sum transfer. So we don't have distributional impacts in the model, so it was just a lump sum transfer. So yeah, fully redistributed, but actually fully taken because the net impact is a negative. So it means that we had to add taxes to finance. So a lump sum, it was a lump sum transfer from households to governments to finance the transition.
Thanks.
And interestingly, I also forgot to mention, so I can build on that to let you think about other questions, but the order of magnitude is like almost half of the carbon price revenues are let's say lost somewhere else in public budgets.
Okay, there's one question from the chat that you can answer. So it's, how do you explain that such results are not better known and used by economic policymakers?
That's a tricky question that goes a bit beyond my competences, but I would say that so far I've seen very little literature on really the impact on public finance, because most models are focused on certain sector and mostly the energy sector. So only general equilibrium model can have like the whole picture of the economy, with some simplification, of course. And actually, they are not the main tool that is used for climate assessment, because IAM models, which are mostly used, are not really dedicated to the economic impacts with such detail that we have here. So that's the first reason. And the other one, I think, would be that there is there needs to be some financing for the transition, and I think carbon price revenue are such let's say viewed as an advantage in the transition that maybe nobody questioned the fact that it could be not really available. I don't know. Yeah, I hope this answers the question.
I hope so too. Otherwise, of course, the others are invited to ask again by turning on the camera or by raising their hand or adding to the chat. Otherwise, I don't see any other raised hands. Yeah, there's another question. I assume you don't include the potential impact of climate impacts in the different scenarios, for example, disaster reserve bonds. I think that's rather a statement than a question, but maybe you could briefly confirm or say if it's different. And then there's a second question.
Yeah, so I agree. We didn't quantitatively take into account the climate impact, but we discussed also the direct impact it could have on public finances. So it's but it's qualitative because we didn't have really good data to use on that. And the second question, which is what are the base assumptions regarding interest rates given their recent volatility? So we have a kind of standard CG approach where we are building we have a capital market which is global, which is limited in movement between the regions, but installed capital is fixed, and we assume that interest rates are fully flexible to adjust. In that sense, it is really not a transition model or a short-term model. It's really relevant in the long run, where we assume that the volatility has somehow adjusted.
Okay, thank you. So now I don't see any more questions. Then I would invite all the speakers again to turn on their camera one last time before we are going to the lunch break. And I want to say thank you that you all contributed to this nice plenary on the new challenges for scenarios. And then we're going to meet again after the lunch break at 13:30 with the first parallel session with presentations. Afterwards, we will have a second session with presentations, and I hope that I will meet you all again there and we'll have some good discussions and presentations afterwards.